Hello everybody, this is Niklas Andersson from Linde. We're just waiting for some more people to join the webinar, so it will start shortly. Hello everybody, and very welcome to this webinar regarding heat pumps and new generation low GWP HFO refrigerants. My name is Niklas Andersson and I'm representing Linde as a product manager for the Nordic and the Baltic countries. And together with me I have Thanasis from Linde, Hans-Dieter from Chemours and Arn from Chemours. I hand over now to Thanasis from Linde.
Hello, and I would like to give all of you a warm welcome. My name is Thanasis Velios. I'm working for the refrigerants business in Linde. I would like to start by saying that Chemours and Linde are working together for more than 20 years in Europe. And since the first day that I joined the refrigerants business back in 2011, Chemours has always been a strong and trusted partner. Together, we have organized numerous seminars and customer events in many countries, inviting hundreds of customers. We have created together brochures, leaflets, and other type of literature, covering many type of new products and applications. We have worked together very hard to educate the markets and lead them towards the transition to the HFO fourth generation of refrigerants. My personal target has always been to create a strong connection between the two globally acknowledged companies. Chemours pioneers products and top quality, matching with Linde wide presence and strong customer focus is a key to success. This success has already been proven by the sales of close to 1,000 tons of XP40 449A in the supermarkets, replacing 404. Now it is the time for another application to follow. Let's hear about heat pumps.
Just 1 second, I was muted. Good morning, everybody. Thanks a lot, Thanasis and Niklas. I will take over from here now, and I would like to welcome you as well. My name is Arndt Lagis. I will do a short introduction of Chemours and give a rough overview about our view on the European heat pump market we see so far. Before I will hand over to Hans-Dieter, who will give us a more technical view of product solution advantages and performance figures. First of all, I would like to welcome you as well. Again, considering the question, you can always put your question in the chat, so then the question will be popping up on our side, and we will come to the question and answer event after Hans-Dieter is finished with his presentation. So you can enter your question at all time. When you have already some, please feel free to do so, and we will answer them by the end of the webinar all together. So yes, let's get into the presentation. As I said, I will start with a short overview about Chemours. We are a spin-off of DuPont, working independently since 2015 in several markets and several segments. The core segment in which we are present with Hans-Dieter and me is the TSS, the temperature, performance, and thermal solution management. These are specialties as well as refrigerants, and there we are looking on or we will focusing during the webinar today to give you a bit more overview about the new generation refrigerants and the advantages in the heat pump market, for example. Then we have titanium technology as another segment in which we are working components for paint, for plastic, for laminates or coatings. We have advanced materials. These are high performance materials which are in different segments, driving, smart drive, automotive and communication. And at the fourth pillar, we have chemical solutions, which are made in the US and mainly for the US market as cleaning and disinfectant solutions bringing to the market. We are working in, we have 58 spots in which we are actively working with 7,000 employees worldwide, and we are acting in 120 countries where we serve customer needs. The European plant is based in the Netherlands, in Dordrecht, and from there on we are serving the European needs of these products being produced or blended in this plant in the Netherlands. Coming to our product range. So we developed over the last years a bright product range to replace former, older refrigerants against newer refrigerants. Our product range is called the XP product range, Opteon XP10, XP40, XP44, and the newer generation, the A2Ls with XL in the front, XL10, 40, 20, 41, XL55. So here you can see, for example, always the replacement product for which the new product was designed. In this case, it's the XL10, which will replace the 134A and which will lead to a global warming potential reduction compared to the old GWP value of 134A by 56%. The value we see, which is quite strictly followed up, which is important and good, to make sure that there's always an advantage compared to older generation of refrigerant to the new ones to reach as well global climate goals and to fulfill the strategy and to be part of this journey. So here you can see that we have as well with the new XL product range with the A2Ls GWP reductions up to 99, 94%, as well here as a replacement for 134A, for example, or here down under for 410A. These levels are upgoing between 45 and 99%. For different applications, you can see here in this pillar of the table that there are different applications for the products in which they can be used. And here you see the flammability rating from A1, not flammable, to slightly flammable A2Ls. And this gives you a rough overview about which products we are talking compared to the older generation of products as well. But Hans-Dieter will dive a bit deeper into these topics in his presentation. So let's continue with our view of the European heat pump market, what we see so far. So compared 2019 to 2020, the journey of the European heat pump market is ongoing and quite strong. So we do not put here in the sales between 2020 to 2021 because we didn't have the figures when preparing the presentation, but the tendency is still the same. There's an increase coming over the last years and which will of course continue. So taking the last 2 years into account, 19 and 20, the years 19 and 20, there we had already a sales increase of 7.4%, 1.62 million units sold across Europe, with approximately 244 million residential buildings. Heat pumps have a share of 6%. Here we can, of course, separate as well, this will Hans-Dieter do later, between new buildings and renovation. So there's always a split in these needs. So for new buildings, you have other things to follow up than for renovation, for example. But for all this, heat pumps are a perfect solution which will be focused on and as well in the near and long-term future. So we see three main trends of growth. So a wider temperature range to enable their deployment in larger share of buildings. So far one family houses, but the heat pumps will be relevant as well for bigger, for other application houses, for bigger buildings as written here. So therefore, as well, a good refrigerant which is able to perform a brighter range is as well needed. There's a need to accelerate the energy transition, brings the heat pump to the center of the attention of policymakers. This is something which is ongoing through all over Europe since a while, that the subvention, for example, for a renovation or for new buildings using energy efficiency technologies is still there. There are subventions up to, I guess, 40–45% if you decide for a heat pump which is pushing the use of this technology as well quite strong. And a third trend is the strong increase of sales and higher lot sizes leads to lower costs. So there's already, due to the higher demand and the higher need of the products, a lot of producers are strongly investing in machineries, in man and woman power to be able to follow up the increasing needs. You will see on the next slide. So here you have as well, again, some older figures, but as well an outlook on some new figures here. So there you can see already the mix between the three different heat pump technologies. So ground source, air water, or air air. So here there's a strong parallel development between air water and air air tendency technology, and ground source as a part which is still small compared to the other two technologies, but which will of course have the needs and increase in case of use as well in the future, taking into account the right hand slide here, for example, where you will see, or where you see that figures, the tendency, the estimation for the figures between 2021 and 25 is approximately that sales will be double. So there will be definitely a tendency in which all kind of three applications will be used quite substantial and strong. So the tendency is, as I said in the beginning, a growth over the last year, which will continue to be growing as well in the near future up to 2025. So the figures are coming from the Heat Pump Association report and what they published. So just as a reference source from where the figures are coming from. So here again, a split to give you a rough idea about how the sales are splitted in between different countries. The Scandinavian countries are quite strong in the use of heat pumps already. So you have Norway, Sweden, Finland, Estonia, Denmark, which are quite good performing in case of share per country in using heat pumps against boilers. So their heat pumps are already have already a much higher share than heat pumps have already a higher share than boilers. Sorry for that. And you see here as well in from the point sales per 1,000 households that Scandinavian countries, Norway, Estonia, Finland, Sweden, Denmark are quite strong already. And other European countries, from the mid-European countries to the South European countries, will follow up. So as well, these tendencies down there are increasing. So the technology is quite strong, and the use of it is already good. But due to the fact that the figures will continue increasing, there will be new developments, new products needed. So the increase of potential for heat pumps up to today and as well in the future is there, and we will be happy to accompany this grow together with you as partners. So this was a rough idea about who we are, what we are doing, and how we see the European heat pump market. And right now, I would hand over to Hans Dieter to continue with his presentation. and give us an overview about energy efficiency, safety, and sustainability. Just again, as a reminder, you can put into the chat your questions at all time. So please feel free to answering questions or when you have already some. And thanks for your attention so far. And Hans-Dieter, the stage is yours.
Thank you, Arndt, and good morning to the audience, also from my side. Arndt, could you please just confirm that my screen is visible? Just to ensure that I don't talk against the wall.
Could you just click again on the screen so that we see that it's moving forward?
Yeah, sure.
Yes, it's working. Perfect.
Okay, thank you. Thank you. Yeah, thanks again for the introduction. And I would like now to go to the benefits of our products in heat pump applications, energy efficiency and sustainability. And for this, I would like to start with a view on. Am I still in presentation mode?
You were in presentation mode and now you left it. Now you are.
Perfect. I just removed the panel, so it switched automatically. Sorry for that. Well, what I'm showing here is the energy efficiency rating in Germany. For each building, this kind of no, don't want to see my camera here. So, no, sorry, I had a small technical issue. Energy certificate, which is used in Germany for each and every building. There is a scale of primary energy on the lower bar in the left picture, and the final energy use, which leads also to a rating from A+ to H, depending on the values in kilowatt hours per square meter and year. So this is the value that is registered here. And so we have a rating on the right-hand side, which is efficiency building with 40, multi-family new building, one family new building, so typical values here on the right-hand side, down to non-energetic reformed single family house, which is rated usually around the G. And I would like to take this as a reference. Why this doesn't work? Here it's coming. I've selected here a typical new building, one family house of 140 square meters, which usually has 5,000 kilowatt hours per year energy consumption, and has a relative final energy consumption of 35.7 kilowatt hours per square meter and year. So this one, which will lead in the scale to a Class A energy efficiency, and a renovation building, the same size, which needs roughly 4 times the energy and has an energy consumption of 142.9 kilowatt hours per square meter and year, and thus leads to efficiency Class E. So these are the reference buildings that I would like to focus on, just to compare the new building and also the reformation building. And you will later understand why I take both, because the efficiency of the heat pump has decisive influence here. Let's have a look on the CO2 savings by a heat pump. This is independent from any special heat pump. We see here again the annual heating capacity, 5,000 kilowatt hours per year for the new building and 20,000 for the renovation building. each for heat pump, for gas boiler, and for oil boiler. For a heat pump, I have presumed a seasonal COP of 3.5, which is the minimum that you need to achieve to bring your heat pump to the market. And an average, European average of CO2 equivalent per kilowatt hour electricity of 0.3 kilogram CO2 equivalent per kilowatt hour electricity. For gas and oil, I've put the CO2 coefficients as given in literature. And comparing these values or calculating them on the annual basis, we find that for a heat pump will reduce the CO2 emissions versus a gas boiler by 61% and versus oil boiler by 73%. And taking into account the Green Deal, where we want to reduce roughly 70% of CO2 emissions, this is the key. Heat pumps are the key to substitute gas and oil boilers to achieve these CO2 emission reductions. Just as a bird's-eye view on why to use heat pumps. I know in the Nordics countries, you are ahead of Central and Southern Europe countries, but it's still a way to go. Back to the view on the buildings that we want to investigate on. The share of new buildings in Germany is just roughly 1/3, and the renovation buildings 2/3. So the bigger or the majority of buildings that have to be worked on and the heating systems have to be updated are the renovation buildings. And this is the major part. This is the bigger fish that we could use and start on reducing the CO2 emissions. Let's have a comparison on the special needs for building renovation compared to new buildings. Starting with the relative heating capacity, as already shown in the former slide, we need roughly 35 watt per square meter for a new building, whereas we need 100 to 150 watt per square meter, roughly 4 times the capacity for a renovation building. So that means also the absolute heating capacity, including sanitary hot water, depending on the size of the building, is 5 to 8 kilowatt for the new building and 10 to 15 kilowatt for the renovation building. So higher capacity, higher installed capacity. The sanitary hot water temperature should be the same in order to avoid Legionella. So it should be 60 degrees Celsius. For radiators and heat exchanger flow temperature, for new buildings, usually you have underfloor heating or wall heating systems with a low flow temperature of just 35 degrees C. But for renovation buildings, usually there are radiator systems which recommend the flow temperature of at least 55 degrees C. This is a challenge for the heating system. Then the maximum temperature lift for sanitary hot water. For outside temperatures of minus 25 degrees C, we still want to prepare sanitary hot water of 60 degrees C, and this is the same for both for new and also for renovation building. But for space heating, there is a huge difference, as already mentioned. We just need 35 degrees C and for the underfloor heating in the new building, also at minus 25 outside temperature, whereas we need plus 55 degrees at minus 25 degrees C outside temperature. That means a temperature lift of 80 degrees C or 80 Kelvin. Then the other disadvantage, the majority of the activities is more than 2/3 renovation building and just 1/3 or close to 1/3 new buildings. So the challenge for the renovation building is even the majority. Here we see a list of refrigerants that could be taken into consideration when it's up to running heat pumps, the one which is most widespread is R410A. A lot of heat pumps are running on this refrigerant, A1, with GWP of 2088. I've listed here two numbers, AR4 and AR5. These are different generations of these numbers, still currently valid. One is the AR4. Let's just look into the future. There are slight adaptations on this. Already the AR6 has been released, but we are still working with the AR4 in Europe. So the reference point will be 410A with 2088 in A1 non-flammable refrigerant HFC, a mixture of R32 and R125. Dedicated replacements are XL55, the R452B, and XL41, 454B, as we have seen before in the overview of the products that Arndt has shared. These are blends, HFO and HFC, based on 1234YF, both classified as A12 flammability, and with much lower GWP 698 for XL55 and 466, slightly below 500, XL41. On the right-hand side, I've listed here R32, which is an HFC, also widely used for heat pump applications and air conditioning, also classified as an A2L, with a GWP of 675. Then finally, not listed as dedicated for heat pumps, I've put here XL20, which is R454C, also a blend of 1234YF with R32. A2L mildly flammable, but with a GWP below 150, which is, considering the F-gas regulation, could be a kind of magic number. So these are the candidates that should be compared. And here I can show you the comparison results from the calculation tool. Left-hand side are the capacities compared to 410A. So 100% is 410A. And the others are here, 454B, 452B, 454C, and R32. So easy visible that the capacities of 454B and 452B are very close to the one of 410A. Just the R32 is in some conditions slightly above. And the 454C XL20 is roughly around 60% of capacity. What are the different bars? These are different operating conditions. A7 W55 means outside air temperature 7 degrees C and water temperature 55. Intentionally, I've put here the water 55 to focus on the renovation building. A2 means outside 2, A-7 outside -7, and A-15 means outside temperature -15. Just as an average over the operating conditions, and these are reference points which are used also to calculate the seasonal COP. On the right-hand side, I've drafted here the COP versus 410A, and we see that for both 454B and 452B, the COP is above 100% above 410A, except for the lower temperatures. Whereas for R32, just at the highest ambient temperature, the COP is slightly above 410A, whereas for lower ambient temperatures, the drop in efficiency of R32 is tremendous. But surprisingly, looking at 454C, the COP for all operating conditions is above 100%, means above the COP of 410A. And especially for the lower ambient temperatures, where we need a higher temperature lift and where we usually have, just from physical conditions, the worst conditions, The COP of XL20 454C is the best and above 410A. So although this refrigerant was not designed as for the application of heat pumps, it shows very good capacity. The only disadvantage here is we need to use a slightly higher capacity of the compressor in order to achieve the same capacity, a little bit bigger compressor. Here, comparison of compressor envelopes for 454C versus 410A. On the right-hand side, these are both rotary compressors, brand highly, it's mentioned here. On the right-hand side, this is a typical 410A compressor with a complete line. This is the standard operating envelope, and the dotted line is with the EVI vapor or liquid injection in place. So without this additional technology, at minus 30 degrees evaporation, we just achieve 35 degrees of condensing temperature. We need the EVI technology to achieve 65 degrees C and a maximum of 70 degrees C, just starting from minus 15. When we look to the left picture, we see that the maximum condensing temperature is of 75 degrees C for 454C. This is the black envelope, whereas for 410A and the other refrigerants, maximum is 70 degrees, and there is a drop down to 45 at minus 30. But for 454C, we can achieve 65 degrees C condensing. That means 60 degrees flow temperature without any additional technical efforts. So this is a standard rotary compressor. That means more simple, easy to use, and cheaper technology. This is also a strong benefit for 454C at low ambient temperatures. Let's have a look on the sustainability, means the emissions, direct, indirect, and total. Direct emissions based on the GWP. It's evident following the GWP values that the lowest values will be achieved with the lowest GWP value of the refrigerant. I've put here a leakage rate of 3.8%, which is coming from a study of year 2014, which is for sure far beyond and far too high compared to standard current state-of-the-art heat pump equipment. So this is maybe even 5 to 10 times too high, but as we want to give here, let's say, a wide scope also the used systems, I've been going here with a 3.8% annual leakage rate. So calculated for the new and the renovation building with the heating capacities and these refrigerant charges. Refrigerant charges multiplied with the leakage rate and the GWP leads to these given numbers here: 10 years direct emissions of 1.46 tons of CO2 and 2.2 for renovation building, and put to 100% for 410A. I've done the same calculations for all the other refrigerants, and we find the 10 years direct emissions for 410A and the reduction for 454C down to 6, respectively 7%. So this is a reduction by 93 to 94%. This is tremendous and should speak for itself. Let's look for the indirect emissions. Here, the efficiency of the system is the decisive factor, which is the SCOP. Again, this is a general one. I don't want to go into details regarding different designs of heat pumps. So this is just a general view on that for both the new and the renovation building. A CO2 equivalent of electricity. Again, 0.3 as an average over Europe. I know that some countries, including Germany, are still above 0.4. Others are below 0.3, so this should be seen as an average, like this SCOP as well. So we will have, during 10 years, 4.3 tons of CO2 equivalent for the new building and 17.1 tons of CO2 equivalent for a renovation building. These are huge numbers. And if we look to the 10 years emissions, both the indirect emissions in blue and the direct emissions based on GWP in orange, we see here the bars on the left-hand side for 410A, the smaller one for the new building and the bigger one for the renovation building, where the orange bar for the direct emissions is quite big. On the right-hand side, we have the same for 454C. For the new building, you see the 4.2 tons. It's the same here because we have preset the same efficiency, seasonal COP. So this is independent from the refrigerant. This is just an average SCOP. If we have a more efficient system, then this bar will be smaller. But what we should take away from here is that the direct emissions, it's nearly not to be seen, the orange bar. It's very, very small. And for the renovation building, it's even bigger difference, a huge blue bar, the indirect emissions just caused by the electricity to make the system run, and a very, very tiny bar, orange bar of the direct emissions caused by the GWP of the refrigerant. Comparing this now for 410A in blue and 454C in orange, this is the ratio of the direct emissions compared to the indirect emissions. So for 410A, for the new building, we had 34% of direct emissions compared to indirect, and just 2.3 for 454C compared to indirect emissions. And for the renovation building, it's even a bigger difference, just 0.9% direct emissions compared to indirect, whereas it was above 10% for 410A. Looking back to the presumptions that we have made, we can say with a lower leakage rate, remember we have calculated here with 3.8% per year, these numbers will be even below 1% for both applications. So this is a tremendous change. And for me, this shows that the direct emissions do not count nearly nothing compared to the indirect emissions. The indirect emissions caused by the electricity to make the system run just can be handled by more efficient system with a more efficient refrigerant. And we have shown before what is the most efficient one. Now, a short step to the aspect of safety, A2L versus A3. We have launched a campaign here on hydrocarbons, the burning truth. For sure, this is a little bit provocative. We don't want to spread the message that propane, which is used most widespread for heat pump applications, should be a bad refrigerant. It is not a bad one. It's a good refrigerant. It's efficient. It's very comparable to 454C from performance point of view, but there are limitations regarding the flammability and regarding the capacity, which is reflected by the refrigerant charge, which is limited to a certain amount. So even if we would like to, we are not able to use propane in all applications. And so A2L refrigerants do have their place in the market and will be necessarily be applied and used to fulfill our Green Deal targets. Regarding the differences, A2Ls are enabling a larger charge size. It's due to the lower flammability. So these A2Ls can be applied for higher capacities. Why it's safer to use? Because it's harder to ignite. You need a higher energy, flammability energy to ignite, ignition energy. A2Ls are less reactive. So even if ignited, they don't react as proper as A3s. So the flame propagation is much slower and lower, and the increase in pressure is neglectable. So it's rather a flame than an explosion if it gets ignited. Some comparative numbers between A2L and A3s. You need typically 4 times more A2L to form a flammable mixture with air. You need 2,000 times higher energy to ignite A2L gases. And A2Ls have by 5 times lower combustion energy. So the energy which further helps to ignite the non-burned refrigerant. The differentiation between A2L and A3 is also processing and coating standards. One big example is the hot surface ignition temperature for A2L. When it's up to hot surfaces, which could be a source of ignition for flammable refrigerant, usually the outer ignition temperature is being used for flammable gases. And for A2L, there is a value which is called hot surface ignition temperature, which is measured to be above 800 degrees C. And taking the same temperature difference between hot surface ignition temperature and 100 K below as the maximum allowed surface temperature, that means you can allow up to 700 degrees hot surface temperature for A2L applications, whereas it is roughly 250 to 350 degrees C for A3 refrigerants. So much higher temperatures can be allowed for A2Ls at the same safety. Ignition sources, the same story. The usage of standard components, PED, fluid group 1, has to be selected for A2L refrigerants. So there is no differentiation between within the PED. Flammable is flammable. There is no differentiation yet, but maybe something to come. There are more different investigations and standards in place that differentiate ignition sources, like switches, like switch gears. So calculation formula which help to allow using standard electrical equipment for A2Ls, which would never be possible with A3 refrigerants, which at the end leads to cheaper and easier to install applications for A2Ls versus A3s. So we are at the end, more or less. Heat pumps can help reducing CO2 emissions for heating by more than 70% versus fossil fuel boiler technology, as shown in the introduction. So the heat pump technology has to grow, has to replace boilers to achieve the environmental targets that we have set. Low GWP refrigerants like 454C or XL20 may cause direct emissions ratio in the range of just 1% or even less. All the components of a refrigeration circuit must be adapted to the refrigerant's properties. That means just a drop-in doesn't work, will not achieve the efficiency that we need to target at. If you remember, the efficiency leads to lower emissions, lower energy consumption, and this helps saving the environment. A2L low GWP refrigerants enable energy efficient, safe, and sustainable heat pump solutions. And using renewable electricity will even improve the heat pump's environmental footprint. So this is, yeah, my presentation so far. Thank you for your attention, and looking forward to receiving your questions. Please note you can put them into the pane, the questions pane. So I will hand over back to Arndt.
Yes, thanks a lot, Hans-Dieter, for this overview of options, of possibilities using A2L refrigerants. Thanks for that. So we could come right now to the stage where we can share some questions which were coming into the chat. You should see us all right now on the screen, all four of us. So I would like to start with the first question which was coming in. I'm summarizing a bit because there are questions, you know, which are with a similar idea or tendency. So one first question, Hans-Dieter, to you. Do we see a tendency for use of heat pumps in case of XL products? So you compared XL 55, 41, 20. Do we see already an advantage for one main advantage or several advantages for one of these products?
Yes, the trend has started and is ongoing. So there are a lot of solutions already in the market. Mainly with XL55 and XL41. So for 452B and 454B, most of the major heat pump manufacturers have already those systems in place. A few already made the next step also to XL20, the very low GWP refrigerant 454C. One of them, one of the major German manufacturers, reports up to 15% increase in efficiency versus 410A. So it's proven in reality already. It's not just pure theory. The systems are available in the market already, yes.
Okay, thanks for that. Maybe one question for Niklas and Thanasis, considering sample availability for these kind of products. Do you have them on average in stock, and how is the way to get these kind of samples in case of need for these products?
If you take the Nordic and the Baltic countries, we have our main facility in Enköping, Sweden, and we distribute throughout our geography, and we keep the old HFC, 407C, 410A, all 32 on stock, of course. But we are also starting to make deliveries and keep stock on new generation refrigerants like 452B, 454B. So we have them on stock, and we can supply them in all of the countries up here in the Nordic and the Baltics.
Okay.
Regarding Eastern Europe and Southern Europe and other geographies as well, we can utilize the two newly constructed plants in Poland and Greece. And we are capable of filling flammable products in both of them. So those can be the two central hubs for the distribution of flammable products.
Okay, thanks a lot. And an additional or another question is, considering the components which are needed to use A2Ls, I guess this is mainly considering compressors and things like this. Is there availability given? And maybe you can say something on that, Hans-Dieter, if you want.
Yeah, sure. There are a lot of products in the market. The most critical part usually is the compressor, the heart of a refrigeration system. There are several products in the market, starting from rotary compressors. I've shown one example in one slide. Different brands are in the market, not just rotaries, but also scrolls and also reciprocating compressors. This development has taken speed during the last 2-3 years. So there is a wide range of products available, not just compressors, also condensing units and subsystems for these products. And the components, control components, are also available. Most of them are available for different refrigerants. So there is not that much the differentiation anymore between A1, A2L, A3s. There are manufacturers upgrade their products in order to have one product line which fits for all. So they do the certifications for the products so that they feel fit for the worst case and can be used for a wide range, because they want to sell it. They want to sell their products and produce them for a widest possible application range. So no problem in terms of availability here.
Yeah, good. You mentioned it already, Hans-Dieter, because this is one question going in this direction: regulation. Not regulation, but what needs to be respected to switch to A2L systems. So then there are some main points to be respected when you want to change to A2L systems. Maybe you can say a few words on this one in case of, you know, checks and the slightly flammability in these systems and with this refrigerant.
Yeah, sure. All the components that are being used in the refrigeration system with A2Ls have to be certified or released for A2L refrigerants. That means the manufacturer declaration has to declare the product free for PED, fluid group 1, for flammable refrigerants, and according to the pressure range that the refrigerant is working in. But this is, as already mentioned, usually already included in the standard range of products. But if you look to an older system, which has been designed for A1, then most probably the components are not fit for A2L. So a retrofit will be a bigger activity. You have then to exchange all the components that are not designed for A2L yet. And for this reason, A2L systems or A2L products are designed for new systems. They can be used as retrofit, but then the complete system has to be reviewed.
Okay, thanks for that. One other question part or pillar I would summarize as, you know, regulation, PFAS topics which come along and which have a certain kind of impact in the discussion at the moment. So there were a couple of questions on the regulatory part. I would just say a couple of words on that. We have a team as well working on these topics. So if there are some formal needs on getting an overview about PFAS, about regulation topic which are ongoing, we are already there to support, because it's a big topic and it's always leading to some discussions. But there are some facts we can always share with you, and we can share with you as well our view on that. So just to give you a rough idea, the PFAS discussion is still ongoing. There are, I guess, 10,000 or up to 10,000 products on the review at the moment, or on a possible list. We are taking care already on these kind of regulatory points with the decrease of our GWP with our XL product range. So there is already an impact with these lower GWP on these environment topics, which are led by the PFAS discussion as well. And we see from our point of view all kind of products needed, which are actually in the market to fulfill the climate and as well as the performance goals. And as Hans-Dieter already presented, direct and indirect emission are, of course, as well a big part of the discussion, taking into account for heat pumps, for example. So again, if you want to go a bit deeper or have a deeper dive in the PFAS topic, we can always fix and propose to organize a call or meeting together. Just this as an information on that topic. So then a next question is it possible in theory to retrofit from R32 to R454B as example? Hans-Dieter, you maybe mentioned already these kind of retrofit or what needs to be respected when things like this are going on, but do you want to give some, are there some specific requests to be fulfilled for this specific example?
Well, retrofit from 32 to 454B, what jumps into my mind, or in general, I already mentioned it, each system should be designed according to the refrigerant that should be used within. It was not, 454B was not developed as a replacement for R32, but as a replacement for 410A. So if it's this direction, then from performance point of view, the system would work, but then it's a change from A1 to A2L, and all the components would have to be checked if they are fit for A2Ls. R32 as a pure fluid has a disadvantage in quite high discharge temperature at very high temperature lift. So you have to take additional technical means to avoid any conflicts to high discharge temperature at high temperature lift. And if you keep these instrumentations or these technical means in the system and use 454B, then maybe you would drop in efficiency. So again, you should adapt the system to the refrigerant that is intended to be used in the system, and it would work, but you would not have the same efficiency. That's for sure.
Okay, thanks for this. Considering availability, as Thanasis, there were just some questions popping in on the topic availability. As Thanasis and Niklas already said, we work closely together to fulfill the needs of the market, to enable the access to as well sample bottles, and there you can always address your Linde partner in your country, and then we can always organize and have a look on how we will solve your needs in this case. So there's just one question popping in here. What is the best alternative for high temperature water systems for replacing a gas boiler in 60 to 80 degree? Do you have an idea on that, Hans-Dieter?
Well, yeah, 60 degrees is already included, so I would propose the XL20. But we also have different refrigerants which are applicable to up to 160, 180 degrees. I'm thinking of R1336 MZ. So yeah, we do have solutions there, but up to 80 degrees, I would go with the standard ones which are designed for heat pumps. 454C, 454B.
Okay. And one last here is, thanks for that, Hans-Dieter. Are there some advantages with R290 in case of, some geographic regions like, North or Central Europe? Do you see some advantages in the comparison we did so far, or you know from the market?
As I mentioned before, when it was up to the flammability, R290 is very much comparable in performance and also operating range with XL20 454C. I would not see there any bigger advantage or disadvantage. Okay. The major difference is the kind of flammability and the limitation of capacity.
Okay, thanks for that, Hans-Dieter. So this was it considering incoming questions. So thanks again from our side. Before I gave back to Niklas and Thanasis, thanks for your attention. Thanks for joining this webinar from our side, from Chemours. Big thank you as well for the cooperation together with Linde. We are looking forward serve your needs together with our partner Linde. And if there are some question, you can always go through your local partner from the Linde entities, and they could forward the question to us, and we are always happy to support you in case of technical needs and technical questions with our team. So thanks again, and Niklas and Thanasis, the stage is yours.
Thank you very much, Arnd and Hans-Dieter. Super nice presentation on the heat pump application area. A lot of things is happening. You can see, for example, in Sweden, there is a lot of heat pumps replaced and sold as new. We are building new houses and stuff like that. So there is a secure demand for heat pumps, and due to the climate, we are also focusing up here on the AC function in our heat pump. So from just asking for warm, nice situation during winter time, we also like to see the cool air during summertime. So yeah, it's changing all over for us. One part which we didn't sort of catch up so much in your presentation is the full PSO from the Linde companies throughout Europe. Of course, we sell both the new refrigerants and also the old HFC ones. We have a full assortment of natural refrigerant. And beside the cooperation with Chemours, we also take care of the waste depending on the regulation in different countries. So we deal with HFC, non-flammable waste, and we also take care of A2L waste. And that would be sort of the new future when you are scrapping down old heat pumps with the new generation refrigerant. We can take care of the A2L waste as well. And of course, we also have the industrial gases with the nitrogen for pressure testing, leak searching. We have oxygen, acetylene for soldering and stuff like that. So we have a full portfolio to support the PSO to our customer in the refrigeration field. So I think that we sit on a strong position for the future, especially cooperating with Chemours and a lot of nice customers to support in the market. So thank you very much, and thank you all for attending to this webinar, and I hand it over to Thanasis to sort of wrap it up. Thank you very much, everybody.
Yeah, I would like to thank you as well. I see a wide range of participants coming from various countries. It's really nice to have all those people attending those seminars. Linde is focusing a lot on refrigerants. We are active in more than 30 countries all over Europe, selling big volumes. We have many plants operational, spread around Europe. And together with a company like Chemours with pioneer technology, products and applications, we will continue to serve our customers in the same efficient way. Please do not hesitate to get in contact either with your local Linde people or with our regional team, Niklas, myself, for any questions or new projects that you might pop up. I'm sure Chemours will be willing to support towards this transition. It has always been like this and it will continue. Thank you all for participating.
Thanks a lot and have a good rest of the day. Bye-bye.
Bye-bye, everybody.
Thank you. Bye-bye.